Hello guys, welcome back to my channel, Boy. It's another Simulkuy episode and we are still on the simulation utility series. On this video, I would like to talk about CO2 freeze out utility, which is very important to be evaluated when we are talking about cryogenic application for natural gas and other stream that contains CO2. So without further ado, let's go to the topic. Okay, so before going to the simulation, I would like to give a little bit explanation about CO2 freeze out utility. So this is an EOS-based approach that is used to calculate the formation of solid in a mixture that contains CO2. So we only can use several EOS such as PR, SRK, PRE thermal, GRG, Spanwagner, and EOSCG. Especially for Spanwagner, I think this is a very popular EOS or fluid package that is used to model a CO2 system. So one note that should be taken about this utility is the utility is based very much with the fugacity of the phase. Yeah, because to calculate the freeze out temperature, we need to find the equilibrium between the solid phase of the CO2 and also the corresponding phase. So here I give note that resultant solid fugacity is something that we can calculate from vapor pressure of the solid CO2, while the corresponding phase fugacity is something that we can calculate from the equation of state. All right, so this is the simulation file that I will use to demonstrate CO2 freeze out utility. So I will like to let you know the component that I use for this simulation. So you could take the screenshot if you want to follow my composition, but actually you can use any composition that you would like to test. But the only thing that you need to have is the CO2, yeah, because we want to calculate the CO2 freeze out, so you need to have a stream that contains CO2. For the fluid package, I will use two fluid package here, PR and also SRK. Okay, so let's go to the simulation environment, and I already prepared one natural stream. This is a gas sample. So the gas is in saturated condition at around 38 bar. Okay, so the composition as shown here, you could take also the screenshot if you want to follow exactly same with me. But anyway, you can use any composition that you want. Okay, so to add the CO2 utility, so to add the CO2 freeze out utility, you can use this utility panel. Then you select the CO2 freeze out and click add utility. Then you could select the stream. In this case, we only have one stream, which is the gas sample. So you could see that the simulation calculate the CO2 freeze temperature, which is around minus 72 Celsius. And the formation flag does not form. So there are several formation flag that you could observe, yeah, such as does not form, and then form CO2, and also the stream doesn't contain any CO2. Yeah. So it between those three. Okay, so in this case, our gas stream is safe from CO2 freeze out. The CO2 freeze out will not happening in this stream. Let's do a little experiment. How if we decrease the temperature below the freeze temperature? For example, I have negative 75 Celsius. So you could see the formation flag will be CO2%, and the simulator calculates how much CO2 freeze out that is available in the stream. This is based on the mass flow you have and the fraction of CO2 that become solid. So it will calculate how much in terms of the mass flow rate. However, if you check from the phase available here, you could notice that you don't have any solid phase. Yeah, you only have vapor, liquid, and also aqueous phase. Why? Yeah, because the function of this utility is to detect the solid CO2, but it doesn't mean that your simulation will have a real solid phase. Okay, so this is only a detection to avoid the CO2 solid. But actually, if we reach the temperature of CO2 solid, there will be no warning, or there will be no real solid formation in the menstrual stream. So it is only by the utility. Okay, so that's it for this video. I hope you get more understanding on the CO2 freeze out utility, and you could apply it if you have any cryogenic application or LNG application. This is very useful utility. Okay, so see you in the next episode. Bye bye.